here we are, back to our long saga of the distance to Andromeda. Recall that if we are here, and let's say Delta Cephei is here, and let's say that the LMC is here. Clearly they're not all the same on the line, but for illustrative purposes, the SMC, and then let's say over here somewhere, okay, call it here, is Andromeda. Okay, we have now found the ratio of distances between Delta Cephei and the SMC, and we found the ratio between M31 and the SMC. So we should be able to find the ratio between M31 and Delta Cephei, but we still can't find any of these things in units that we know, like astronomical units or parsecs or light years, because we still don't know the distance to Delta Cephei. This is often the case in astronomy. It's very often that we find ratios of distances before, often many, many years, sometimes centuries, before we actually find the real distances. We usually imagine climbing what we call climbing the rung of the cosmic distance ladder. So we imagine that we had some sort of ladder that we were climbing. You know, like here's a ladder, and here are different rungs, and here's where we are, and then we find distance ratios on the way up. Often we will find historically ratios between things that are further away before we have found the distances to those things. So in our particular case here, if we imagine that this is M31 and this is SMC, we found this ratio there, and let's say we found some ratio of distances to Delta Cephei. We still do not know the distance from here to Delta Cephei. Until recently, that could be estimated by finding the distances to some other things sort of along the way, star clusters, things like that. But recently, Delta Cephei's parallax has been measured. And so rather than, we're talking 100 years after, all the other observations we have to here, well, at least now Delta Cephei has been measured. It was in the early 2000s. So not quite 100 years since Levet, but really close. So now, recall that the way that parallax works is we imagine, let's put the Earth here, and the Earth goes around the Sun. We'll put the Sun here. And the Earth orbits the Sun like that. Now, the distance from the Earth to the Sun is 1 astronomical unit. Now, if we observe Delta Cephei over the course of a year, it's going to look like it wiggles back and forth in the sky. And it might even move in a particular direction, look like it's sort of wiggling and moving. If we measure that wiggle, whatever that wiggle is, then we can measure the angle subtended between here, Delta Cephei, and here. So, we'll draw that out as a diagram. So this point here is Delta Cephei. This angle there we're going to call theta. And this distance here, the baseline, is 1 AU. Which, if you now imagine that this is the wedge of a circle, this is what we call S in the small angle formula. Because the circle is centered here, and you have a huge imaginary circle with Delta Cephei at the middle. So, this is what we're looking for. And now we can use the small angle formula, or we can decide to use the small angle formula in ratio form. And in ratio form, we know that the distance times the angle must be proportional to the arc length S, or the radius. I'll put my radius here. So R is proportional to S divided by theta. So if an AU were bigger, right, if our baseline were bigger, we could find the distance would be bigger. And if the angle were smaller, the distance is bigger. This is called the parallax angle. And so we have to solve everything in ratio. Now we know the definition of 1 parsec is when the parallax angle is 1 arc second. Now, we were given this in units of milliarc seconds. So if we come back and read the question statement, it says, neither Leavitt nor Hubble could directly measure the distance to Delta Cephei, and their distance estimates were highly uncertain. Over the years, astronomers tried to measure the distance to it and to the Small Magellanic Cloud via other methods, and the measurements improved throughout the 20th century. In the early 2000s, the Hubble and Hipparcos space telescopes measured the parallax angle of Delta Cephei to be 3.77 plus or minus 0.16. Notice something cool. The Hubble Space Telescope is named after Edwin Hubble, who we just talked about, and the Hipparcos Space Telescope, Hipparcos, is named after Hipparcos, the person who set the magnitude system we just talked about. And so 3.77 plus or minus 0.16 milliarc seconds. Notice that there's sometimes a different transliteration from Greece, because Greek used a different alphabet. How far away is Delta Cephei? Expects your answer in parsecs. So, right here, we have 3.77 milliarc seconds. Notice milli, just like a millimeter, there are 1,000 millis in whatever we're talking about. So there's 1,000 milliarc seconds in 1 arc second. So this is the 1 parsec standard, has a baseline of 1 AU, a distance of 1 parsec, by definition, a parallax angle of 1 arc second. That's why astronomers use parsecs. Now, once we're here, we can write this as a ratio. So, that's what we're looking for, so we put in the upper left. And that's a 1-to-1 ratio. And this here is a 3.77 to 1,000 ratio. And that's going to be equal to 1,000 divided by 3.77, or 1 divided by this ratio. And to see that, we can put our calculator here. There it is. And we can say 1 divided by, open parentheses, 3.77 divided by 1,000, close parentheses. It's 3.77 times the negative third equals, that flipped it over, 265. We could have also said 3.77 divided by 1,000 equals this, and then flipped it over with the 1 over x button, which is right there on this calculator. Okay. Or we could just said 1,000 divided by 3.77, and we get the same thing either way. So we have 265. Multiplying both sides by 1 parsec, we can say now notice something. We were given an actual error bar here of 0.16. So that error there is 0.16 milliarc seconds, and let's divide into it its corresponding value, which is 3.77. So we have a 4% error in this value. So if I multiply this by 265, which is our answer, in parsecs, we get about 11. So our answer is it's basically between 255 and 275 parsecs away. So that's the distance to Delta Cephei.